The title of our project is Knowledge Fusion for Probabilistic Generative Classifier with Data Mining Applications in the domain Data Mining. Let's see the brief explanation about our project. A classification. A classification is a task begin with a data set in which class, assign or known. That is, we are classifying the data based on the data sets. That is, the classification may be in n number of parts. With the n number of parts, we are going to combine the data. That is the main task in our project. We introduce a new fission classifier at the level of parameters of classification rule. This technique is based on the use of probabilistic generative classifier using multinomial distribution for categorical input dimension and multivariate normal distribution of the continuous one. That is, the classification is a probabilistic generative classifier. That is, we are classifying the data based on the probability, and based on that probability we have a parametric value. With the parametric value we are going to fission our data. The fission is nothing but we are going to merge our classification in a probabilistic manner. The main advantage of the fission approach is a hyper distribution are retained through the fusion process. Degree of belief distribution to distribute our data sets. The data sets were get distributed, but the knowledge of the data sets were be low, and the high with the number of real data exists, we are classifying the first data, and in the second rule of our classification is done with the probabilistic classifier, offer with the possible combined classifier at the level of component of mixture model. In our third part, that is our third rule, we are going to fuse both two data classifiers. That is both classification 1 and the classification 2 based on the probability. We are going to classify our data. The main approach, we are classifying the problem and we assume the probabilistic generative classifier are used to solve this. Probabilistic classifier provide outputs that are interpreted to one conditional probability. That is, we are going to classify data based on the input and the output of the data. We have several that is done with 5 folds of probabilistic manner, such as if we consider the classification once based on the probability, that is, if we consider the probability 1, 5, we have the probability manner as 1, 1, 1, 2, 1, 3, and 1, 4, and 5. Based on the probability, we are going to classify the data, and at last we are going to fuse our data. The main advantage in our proposed manner is that the class positional probability are very useful to weigh a single decision, and a rejection criterion could easily be defined. In a dynamic environment, it is possible to detect novel situations. Let's see the flowchart of our project. This is our flowchart diagram. On the first stage, we are going to extract our data sets. The data set may contain more than 1,000 and values of data, and at the next level, we are going to classify our data. The classification is done based on our rule. That is, we are going to classify data for both classification 1 and classification 2. And with the classifications, we are going to classify the probability we are going to do the 5 folds of probability classification. That is based on the positional values and the parametric value. We are going to classify our data in a 5-fold, and we are going to further distinguish a positional classification. The positional classification is nothing but we are going to position the data. That is, we are going to parameterize the values of the classified data, and we are going to find the similar parameters. With the help of the similar parameters, we are going to fuse both the classification 1 and the classification 2. That is based on the join and the union operation. We are going to classify these two data, and at last we are finding the fission result. This is about our flowchart diagram. See the demo of our project. I click on this view data. Now my data set has been extracted and the data has been viewed. I have an extraction as age, work class, final weight, education number, and the marital status. And when I click on this proceed button, now I am going to the next step, that is the generating classification rule. This is actually our first model. We are going to generate our classification based on the rule. That is, we learned already the classification 1 and the classification 2 rule. At last we are going to fuse those two rules, and the rule 1 here I found that I have classified my data where get extract my data where get stored, and when I click on this rule 2 button, my next classification rule of data where get extracted, that is age, work class, final weight, and the education number. And when I close with the positional value, this is saying here to save my data. And when I click going into the next process, then my next process will be in the form of 2. And when I click on this classify 1 button, here I have founded the classification 1 data sets, and when I click on the same similar data will be get provided here. Here I will be founding the education and not the education number, and here the second level of classification I have found the education and not the education number and not the education. And when I click on this include button, these two sets of data will be gets loaded into our data sets. And when I click on this dimension button, at the first level of dimension, here we have and dissimilar data as the education, and same as in dimension 2, here I found the data sets as education number. I just choosing any of the data fuse our algorithm. That is, now I am clicking on this fission button. Here I have found this is actually the how the fission will be formed with the help of classifier A and classifier B. I am combining the both two data. Here I have found the classification A with the I have found a green color graph, and the red, and in the form of at the last we found the classification B extras. We have a brown color data, and at last we are fusing both two, joining these two data. And when I click on this button, here I have found it, and my process has been completed. And when I click on this dimension view button, here I have found the dimension of categorization 1 and the categorization 2, that is the classification. Here I'm just clicking on this view dimension, the dimensional view for the classification 1, classification 2, and the fission classification were get found, and it will be implemented only with the help of convergence matrix. The convergence matrix will be found with the help of this form, that is a dimension 1 into dimension 2, that is a formation of convergence matrix. And when I found the CMM parameters will be found with the help of vector values, and the vector value 1 and the vector value 2. The vector value will be designed with the help of this formula, and at last we are founding a hyper distribution. And when I click on this next button, this is our next module, that is a probabilistic classification 1. The classification will be done with the help of probability manner. I'm just clicking on this button. Here I found values will be get included. Actually, how the classifications will be done will be in the form of input and the output. The input values will be matched with the output value, that is the probability of final weight, and the age will be get designed here. And the same thing, the probability of final weight and the marital status will also be included. And when I click on this next button, the education and the age where we get designed, and the same thing, marital status will also be get designed. Now the probability of 4 folds will be get founded over here. And when I click on this classify 2, the same process, the same thing will be for classification 1, and the classification 2 also will be designed. Here I am going to found the data will be in the 4 fold, that is the final weight will be also in the age, also in the marital status. Now I found it with the final weight with an age. This is actually a work class will be in a positioner value, and the same thing will be found for a marital status. The classification 2 will be found. And when I go with an education number with a probability, I'm founding with the age. Found and values, the word class will be in the form of positioner and the probabilistic values. And now I am going with the marital status. The same results will be found with the education number, probability of an education number, and the marital status. Now I just clicking on my next button. This is actually my next module, that's the fission technique for classification 1. Now I am going to fusion my classifications rules, that is with based on our fission techniques and our VR training algorithm. We are going to find the positional value at the first, and we are founding a likelihood and a likelihood. That is, we are founding the two values at the classifications once, one value into priority value. That is a classification 2 with the classification 1 with the second value with the priority. Both will be get combined and form into prior value. That is only here I have found. That is, first I have founded the positioner value, then I found the likelihood 1 value, then this is actually the likelihood 2 values. That is, here when we found here the final weight and the age will be get found, and the work class, the positional value will be found. And when I go with the likelihood 2, here I have found the work class, final weight, age and the marital status. When I click on this probabilistic button, I have found that the values were get merged and the formation of position. My process has been completed, and when I click on this get value button, now I have found the similar likelihood of the values of our data set. And when I click on this next button, here I have found the fission technique for the classification 2. For the classification 2, the same thing, we are going to find the positional value and the likelihood. The likelihood 1, we are finding the final weight and the age alone. And when I click on this likelihood 2, I have found out the value of final weight, age and the marital status as the additional thing. And when I click on this include button, my values will be get stored. When I click on this probabilistic button, now I have found the education number is also get included in our sets. And when I click on this include button, the data will be get stored. Now I am going to get the value of the likelihood and click. Now I am going to fusion, that is I am going to combine all those values. Here I just combine all those values and find the value of a multiple manner, and just I am going to just include all those values in my data sets. And when I count the value, the real sets of data which is found is 8603. And when click on fusion, the hailing distance, that is based on the data sets values will be found, and the continuous and the hyper distribution is also found, that is also called as Bhattacharya coefficient value. And when I click on this fission with chart, when we go with the fission with chart distribution, here we have found the fused values, that is the first normal distribution, second normal distribution, and the fission, that is based on the first classifier, second classifier, and at last we are finding the third classification process will be get loaded here. What has been occurred, we are going to distinguish is, for first we are checked with the test error of classification 1, that is a detected error value is 610450, but the actual error found is 4960. The rest of data were be get pasted, and the same thing for classification 2, and it's a whole sets of data. And when we click on this view graph button, the error of classification 1 data sets will be found, and the same thing for classification 2, and the result will be found. Thank you.